Welcome. In this video, I'm going to go over the 6 Paper 1 questions from Part C, D, and E of Section 9.1, which is mostly looking at oxidation states in redox equations. So the half reaction, what's happening to your oxidation number, oxidizing agents, reducing agent, those type of questions. So question 1 says, what will happen to the manganese in the following reaction? So on the product side, it's easy to see that manganese has an oxidation state of +2. On the reactant side, with MnO4 minus, I know that I have 4 oxygen at -2 each for a total of -8. And since I want a -1 charge overall, that leaves a +7 for the manganese. So manganese is being reduced from +7 to +2. So D would be the correct choice there. It's reduced. When oxidation number is reduced, that means it's gaining electrons, so we call the process reduction, and the oxidation number clearly decreases. Question number 2 wants to know which are redox reactions. So you have to look and see if one atom is losing and another atom is gaining electrons. And the only way that I know how to do that quickly is to go ahead and look at the oxidation states. So FeCl2 plus Cl2, Fe is a +2 here since it needs 2 chlorine, but it's a +3 here since it needs 3 chlorine. And I can quickly see that the chlorine is changing because it's 0 here and a -1 here. So 1 is definitely a redox. 2, Mg is going to go from 0 to a +2 charge, so far so good. And hydrogen is going to go from a +1 to a -1, so I don't even have to look at the nitrogen and oxygen. I have enough information to know that, yes, that's a redox. On number 3, hydrogen's a +1 on the reactant side, but it's still a +1 on the product. Oxygen's a -2 unless it's with fluorine, so it's going to be a -2 in every place. So looking at sulfur, I don't even need to bother because sulfur can't be oxidized and reduced since it only shows up one place on both the reactant and product side. So 3 cannot be a redox. So I know that A is the correct choice. 1 and 2 are redox reactions. Number 3, this looks similar to number 1, involves permanganate, MnO4. Which statement is correct? MnO4 is the oxidizing agent and loses, so it's all about MnO4. So let's look and see what happens to MnO4. We just had this one. We know that it goes from +7 to +2, so reference back to number 1, and you see that it's being reduced, which means it's the oxidizing agent, and it's losing electrons. I'm sorry, it gains electrons. So it's being reduced, it's gaining electrons, it's the oxidizing agent. So C would be my correct choice. Number 4, you have to think about this a little bit. It says, which list represents the halogens in increasing order of oxidizing strength, weakest oxidizing agent first? So oxidizing agent means it's going to be reduced, which means gaining electrons. So for halogens, gaining electrons is a good thing. So that would be most reactive. The most reactive halogens will gain the electrons. And you should remember that the most reactive halogen is fluorine because it's the smallest of all the halogens. And then the reactivity decreases as you move down to iodine being the least. So in this set of choices here, iodine, bromine, and chlorine, iodine is the least reactive, and chlorine is the highest or the smallest, so it is the most reactive. So B would be my correct choice. Number 5 wants to know which species is the oxidizing agent and which is the reducing agent. So this is which one's reduced, this is which one's oxidized. So as I look at my equation here, H2O2, I have to look at what changes there, the hydrogen and the oxygen. Well, this is a case where oxygen is a -1 because it's peroxide, so it's going to become -2 on the other side in both species that it's contained in. So going from -1 to -2 is a decrease in oxidation number, which makes H2O2 an oxidizing agent. It's gaining an electron and being reduced. So H2O2 is an oxidizing agent. So then if I look, I have to decide if H2SO4 or FeSO4 is the one being oxidized. So I'll look at Fe since it's the first one here. Fe over here is a +2 to balance that SO4, but over here it must be a +3 to balance the SO4, because we know SO4 ion always has a -2 charge. So if it's going from +2 to +3, I know it's being oxidized, so that would mean B is the correct choice. And I can double check by looking to see what happens to H2SO4, and my hydrogen remains a +1 and my SO4 remains a -2. So B would appear to be the correct choice. 6 wants to know what happens to iodine when iodate ions are converted to iodine molecules. Well, the easy part is that you know it's going to 0. But the question is what did it start as? Well, if I have IO3 minus, I have 3 oxygen at -2 each for a -6 charge. My charge overall has to be -5. I only have 1 iodine to make that happen. So iodine has to be a +5. So it's going from +5 to 0. So the question is that oxidation or reduction? And that's reduction when your oxidation state goes down. You're losing control over electrons. So C would be the correct choice.